We are in the National Vegetable Protected Cropping Centers, and this facility was built in 2017, and the facility is funded by Western City University and Hort Innovation. And the objective of this particular facility was to be able to grow crops under ideal environmental conditions for highest productivity. And so the project that we're running with the CRC is one to look at different films that can be applied to a glasshouse. And the reason we're testing these different films is one of the primary costs to growing is energy costs. And so working with some of our partners, we found a glasshouse film that is commonly used in office buildings. It gives you that nice light routine. And the idea behind the film, it was designed to reduce ultraviolet light, so people wouldn't get sunburns inside, but also to reduce the high wavelengths of light. And high wavelengths of light are heat generated. So we applied these films in here, and we were trying to determine whether we could save energy, but also we were concerned that there might be some impact on crop production. So what we really found was that the films that we were using do save some energy. They're able to reduce the heat load inside the glasshouse. But there is a penalty yield. So unfortunately, in the different crops that we ran, there were reductions in the yield of the crop. So we were producing fewer fruit, but we didn't see any change in the quality of the fruit. So if a grower were to select a film, they would want it to be able to save energy, but also not affect the production of the fruit. So this particular film that we originally trialed, I would not consider it to be very successful, but it did give us some pretty tremendous insight into the next generation of film. So our newest project with the CRC, the really large foundation project, which we're pretty excited about, is redesigning that film. So now we know what the spectral characteristics are of the film. And so we have working with an industry and focus and with another university or MIT. And we've redesigned that film. So it's going to let some ultraviolet light in, which is important for plant development. It's going to let in more of the red light, which it was inadvertently reducing, which was causing the yield penalty. And it's going to cut off more of the high wavelength light, which generates heat. So our original project was really informative, even though we didn't find the holy grail of films. It allowed us to generate the next generation. The first CRC project, so when we were initially funded by Hort Innovation, we were just using the smart film. And then when we were contacted by Alex a few years ago, he had the leaf film. So what we did is we then added 2 extra bays to our facility in using leaf. So now what we've done is we've got a clear bay, which is haze light, just glass from the Netherlands, which diffuses about 70% of the light. That's what we call a control. We then compare that to our smart film, which was the original film, and we also then compare it to our leaf film, which is the red film. The real advantage of having a facility of this size, and all the bays are replicated, so we have 2 bays of each, is that we can do comparative studies. And these comparative studies are really important. So photo period, the length of daylight is important, the season is important. And so if we were to run one film under one set of conditions and then another film in another set of conditions, we wouldn't really have to do comparative. Whereas here, we're able to compare these films.